Yes, class. Good evening.
Good evening, ma'am.
Good evening, ma'am.
So, Akifa, Atif, Fatima, Hamza, Hanifa, Huzaifa, Krishna, Sarah, and Zain. All right, class. So, in the last class, we had started with Young's double slit experiment. So, we could complete only till the equation of the resultant wave. So, just let's quickly revise what was this Young's double slit experiment. See, in Young's double slit experiment, a slit, two slits are there. You also have single slit experiments. Right now we are considering double slits, and a source is there. As the waves are produced, both the slits have vacant spaces and they allow the waves to pass through it. Now, when the waves pass, as the waves will pass, what will happen? They will start overlapping on each other. Now, if the crests of the wave overlap with each other, so superimpose on each other, or the troughs of it, fine, overlap with each other or superimpose each other, that results in bright fringe. You get a very bright space. Space, you can say, image, you can say, color, you can say white space. Even the type of source, if you use, even if you use laser light, you'll obtain red color. So bright fringe you will obtain. Bright does not mean something yellow or white over here. It means color is there. Dark fringe means absence of color. So in case of dark fringes means there are empty spaces. Now see, and if the crests or the troughs of the waves, they overlap with each other with trough and the crest, or the crest and the trough, like this for both the waves, then that results in destructive interference, you can say, or you can even say dark fringe. Dark fringe basically means what? Dark fringe and bright fringe, understand. You have colors in the form of rectangles or slight vague appearance, you will observe it. And then after that colored part, there will be a space, vacant space, where no colors will overlap. Then after this, again a space will be there where color will there. You will obtain bright color band. Then again no color will be there. So where you will be obtaining all these brightly colored bands, so that we call as bright fringe. And the spaces where no color is obtained, that is known as dark fringe. So equation of the resultant wave also we did. Y is equal to sine omega t plus theta. Let us quickly see the equation. Yes, intensity also we'll do it in detail. Intensity of resultant wave is left. Amplitude of the resultant wave is left. What else? Equation of resultant wave we did. So see, intensity for individual, these are the individual waves with which we had started. These are the individual waves with which we had started. Fine. Now, intensity is always proportional to the square of amplitude, whatever is the amplitude. So even if it's the resultant intensity will be proportional to the square of the resultant amplitude. Fine. So two waves are there. They are superimposing each other. Two waves are moving. Two waves are in motion. Now, your concern is what will be the final wave that you'll obtain for all the fringes. Regarding the length of the fringes or what is happening to the fringes, angle that is subtended by the fringes, that we'll see later on. But right now we are focusing on the simple superposition principle. That if two waves are there, A is the amplitude of the first wave, B is the amplitude of the second wave. What should be the equation of resultant wave? So I think two equations we had derived. Yes, these two equations are very important for the complete derivation. Amplitude of resultant wave is taken as capital and theta is the phase, resultant phase. Fine, everything will be resultant. There will be a resultant, no net resultant, net phase difference, net path difference, net amplitude, because two waves are there having different physical quantities. Fine, class. Now see, when we did this, so we came to the conclusion that y is equal to r sine omega t plus theta. So y is what? Y is now the resultant displacement. Individual displacement was what? Y1, Y2. Now this is Y. R is not some new amplitude. This is actually the sum or combination of both the amplitudes of those equations, A and B. A amplitude from Y1, B amplitude from Y2. Then sine omega t plus theta. Theta is resultant phase difference. will be there for first one, some angle will be there for second one. What will be the resultant phase difference between them? That is taken as theta. Also, now R you know, but how will you calculate R? A is the amplitude of the first wave, V is the amplitude of second wave. Right, we know the amplitudes. We know resultant is denoted by this symbol R. But we don't know whether to add it, subtract it, use parallelogram law, use dot product, cross product, how to find out the result. That we are not aware of, no. So let's calculate the resultant amplitudes equation, that how will you find the value of this R? How will you find the magnitude of this R? So again, we'll use these two equations only. A plus B cos phi is equal to R cos theta and B sin phi is equal to R sin theta. Let's square these and add. Squaring, adding, squaring, adding. So if we square and add these equations, so wherever you stopped writing in the last class, just continue from there only. Because in your exam, if the derivation comes, usually this derivation is not asked in your exam. If the derivation comes, you can write it in a continuation. So square and add 1 and 2. So first one was A plus B cos phi whole square, getting added to the second one, which was below it. That was B sin phi. So B sin phi whole square. And now this is what we have added the left terms together, left hand side terms. Now we have to add all the terms that are towards the right, RHS. So one was R sin theta, second one, other one was R cos theta. So this becomes R square cos square theta plus R square sin square theta. So this is how we add it, get the resultant of all of the equations that we have. Now let's open up this A plus B whole square. We can use this identity where your B is not just B, but B cos phi, right? So this becomes A square plus B square cos square phi. Fine. A square plus B square plus 2AB. Fine. This is a simple trigonometric identity. Similarly, this is simply B square. This will become B square sin square phi. This is equal to R square. Let's take common. So what is left? Cos square theta plus sin square theta. So what is cos square theta plus sin square theta? Yes, cos square theta plus sin square theta. This is it. Yes, someone was answering.
It's 1, ma'am.
Yes, 1. It's correct. It's 1. So here also let's do one thing. A square, let's leave it here. 2AB cos theta also let's keep it here. 2AB cos phi. From here, let's take B square common. So if you take B square common, no, we are left with cos square phi over here. Plus, from here you are left with sin square phi. B square has been taken common. And here R square. And what was left? Cos square theta plus sin square theta. Now see, both of it will be 1. This entire term, because of the trigonometric identity, this will be 1. And this is also the same identity, no? Cos square theta plus sin square theta. Just theta is phi over here. So this will be 1. Now see, what's your resultant? R square is equal to A square plus B square plus 2AB cos phi. So R will be what? A square plus B square plus 2AB cos phi with an under root. So this is what this equation you will use if you know what is A, if you know what is B, and you have to find out the resultant amplitude. AB, you know. A was from where? We had obtained A from the first equation, y1 is equal to A sin theta. From there you have the amplitude. And B is obtained from the second amplitude. So this is amplitude of resultant wave. And this is important because numericals come from here. Numericals that you have, they are from this equation. So this equation, more than the derivation, you have it in your numerical form. So resultant wave. So numericals will be there from this. AB, either AB will directly be given to you, or two equations will be given from where you have to identify what is A and what is B, right? And this equation will be used in numericals, fine. One more thing that is less likely to be used, but we have to find out what is this direction of it. As in direction in the sense, theta. What is this phase difference? How will you calculate phase difference? So if we divide both these equations, because we have to find out theta, let's divide 2 by 1. So see, if you divide 1 and 2, it was B sine phi on the left hand side, and on the right hand side you had r sine theta. In the denominator you had a plus b cos phi, and here you had it as r cos theta. Why are we dividing it in such a manner, or why did we add squared and add it in the above? We squared and added in the above so that we could get rid of the sine theta and cos theta, and the only way to get rid of it was by using that identity. And to obtain that identity, to artificially make that identity, we had to square and add it. Now what is happening? We want to get, maybe we want to just find out theta, so we want to shorten it up. So what's the best thing? If we cancel it, sine theta by cos theta will directly give us tan theta. So now tan theta will be b sine phi by a plus b cos. If you are able to notice this, both of these are very similar to the parallelogram law that you've studied. This is tan phi. Fine. Then we have intensity as a resultant equation as well that we'll see later on. So these two, from tan theta, numericals can be asked, but more numericals are asked from amplitude of resultant wave. All right, note it down from here. Any doubts you have asked? See class, from here, yes, I told you in the last class that I1 is equal to K A square and I2 is equal to K B square. So intensity, this is the individual intensity. For this wave, intensity will be I1, that is Ka square. For the second wave, Y2, intensity will be I2, that is Kb square. But what about the resultant? How will you write the resultant intensity? So for that, we'll use this only. See, if intensity is proportional to the amplitude square, so resultant intensity will be proportional to resultant amplitude square. Individual intensities were proportional to square of individual amplitudes. So resultant intensity will be proportional to square of the resultant amplitude. And resultant amplitudes equation, just now you all have also written it. So see, intensity resultant, this will be K. R is what? A square plus B square plus 2AB cos phi under root whole square. This is R, complete square of R. So resultant intensity will be K. This is A square plus B square plus 2AB cos phi. And this root and the square will cancel each other. Half is the power and 2 is the square. So both will cancel each other. This will be remaining. Let's multiply K. So that makes it Ka square plus Kb square plus 2Kab cos phi. Now one thing class, tell me, what is root K multiplied by root K? What will I obtain? Root K by root K into root K.
K.
K. Definitely K. Yes, Sara and Krishna, it will be K. Now see, so it means I have this K over here, right? So K means root K into root K. I can write this K as root K into root K. So let me first write it, then I'll tell you what is the final equation. Ka square plus Kb square plus 2 root K into root K, I can write it as root K into root K. This K has been written it like this, same thing. And what is left now? AB cos phi. Now see class. Ka square. Can anyone recall? Just now I have told you, what is Ka square? Anyone? Ka square before we... I1, yes. I1. Good, Krishna. First intensity. Remember class, I1 means intensity for the first equation, for the first displacement wave. That was, amplitude was A. So I1 will become what? I1 will become Ka square. Similarly, Kb square is what? That is Ib you can say or I2 you can say, right? So it means IR. This can be written as I1 plus this whole term is I2. Now see what is left over here. From here we have 2. I'm writing this together and this together. Root Ka, root Kb cos phi. Now see class 1. I1 is equal to Ka square. So what will be A only? Or if I square both the sides, take root on both the sides. So that will make it I1 root is equal to under root K into A. Similarly, what about I2? I2 is Kb square. So if I take root on both the sides, this will become under root I2. This will become under root K. And under root B square will give me B only. So it means under root Ka. Now look over here. If you look from here, this is under root K. So this can be written as under root I1, right? Root Ka, root I1. Similarly, root Kb, which can be written as under root I2. Now you have the equation of the resultant intensity. So this is I1 plus I2 plus 2 under root Ka can be written as root I1 into root I2. Now cos phi out of the root. This is the equation of the resultant intensity. And again, this is also important from the numericals perspective. Derivation can also be asked, but maximum chances are there you will get direct proper numericals. I1, I2 will be given, or amplitudes will be given. First, you will have to calculate what is I1, I2, and then find out, or somehow you'll have to find out what is cos phi. Rest of the things will be given. It can happen cos phi is not given. So we did a relation between path difference, phase difference. Maybe using that, you have to find out cos phi. So either phi, that is phase difference, or I1, I2. Any of these things can be unknown. Or it can be resultant intensity is given to you. One of the intensities is missing, and that is asked by you. So if any of these is asked, just write it down using this equation. So what I'm trying to say is this equation and the resultant amplitude equation. Both these equations are very important for you to remember it and learn it. Fine. So try to learn it as a formula only. The complete formula, the complete equation, try to remember it. So note it down. Any queries, any doubts you have, you can ask me. Yes, class. Now see, I've discussed with bright fringes and the dark fringes that are formed. Somewhere you obtain bright colored bands that are known as bright fringes. Somewhere where you do not, alternatively where you do not obtain colored bands, that space, that vacant dark space is known as dark fringe. Now, see, there's a certain condition for it. If we categorize certain conditions, then it will make our work easier to find out about what is the resultant amplitude for bright fringe, what is the resultant intensity for bright fringe. See, this is for general, what we have written till now. This is for general. What if you want to know just about the bright fringes? What about just the bright fringes? If I tell me the resultant intensity of the bright fringes that are formed, all the bright fringes. So how will you find out? You have the mixed waves. So we have to have certain conditions, no, specifically for the bright fringe, specifically for the dark fringe, that we are going to do. So see, since this is formed by constructive interference, we call it as constructive interference bright fringe, as well as we say it maximum. Why maximum? Because maximum amplitude you get this time. Resultant amplitude is maximum. The value of resultant amplitude is maximum. Value of resultant intensity is maximum in case of bright fringes. So you can use the term maximum if the term bright fringe is mentioned to you, if the term constructive interference is mentioned to you. Either of these terms are mentioned, use whatever we are going to do it right now. All right. So even if the term is interchanged to you in the exam, do not get confused. It means bright fringe. Wherever anything is maximum or constructively interfered, or just the term constructively is mentioned at the end, so it means it is talking about the bright fringes that are formed. So see, equation of resultant intensity is what? Not intensity, resultant amplitude. Resultant amplitude is what? A square plus B square plus 2AB cos phi. Fine, this is the resultant amplitude. So what will be the amplitude if two waves are constructively superimposing each other? It means both the crests are on each other, right? Or if I say, let's talk about the troughs. So both the troughs are together. It means even if one crest has, let's say, 3 millimeter, let's say amplitude, other one has 5 millimeter. So it means this will be a combination of 3 and 5. So in case of bright fringes, what is happening? You are getting maximum amplitude that is greater than what is obtained, what is of the individual waves. So that's why here we'll be having the maximum resultant amplitude. Now, for this quantity to be maximum, this quantity has to be maximum. So for R max, remember this condition. Cos phi at anyhow has to come 1. Because this is the maximum value of cos theta, right? You cannot have cos theta as 2, 3, 4, 5, 6. 1 is the maximum value of the cosine curves that are present, or the cosine values that are present in trigonometric tables. 1 is maximum. So we want to have it as cos phi as 1. Then only we'll get the maximum value of this quantity, because this quantity is dependent on this quantity. So in order to have this maximum, we have to have this maximum, because we cannot change this. We are finding out this. This is unknown to us. This is in our control. So cos phi is 1. Now see, for whenever you have cos theta is 1, you can take it as 0. Cos 0 degree is 1. You can take it as 2 pi. Cos 360 degree is 1. 2 pi, 4 pi, you can take all the even number times the pi. It means 2 multiplied by any number that you take. That will make it even. So let's say 2n pi you can take. Like if I say 2n pi can be the phase difference, this means n is any number starting from 0, then 1, 2, 3, 4, 5, 6, any number that you choose. For example, choose a number, let's say 5. N is equal to 1, 2, 3, 4, 5. It's a 5 I have chosen. So what will be the phase difference? 2n pi. N is 5. So that means 2 into 5 into pi. That is 10 pi. So it means you will be having the phase difference as 10 pi. So 0, 2 pi, 4 pi. Any number that you take starting from 0. It should be 2 multiplied by that number multiplied by pi. That will give you the angle. So even if sometimes you have to identify whether it's a condition of maxima or not, you can use this trick. If the phase difference is setting in this equation 2n pi, it means it is constructive interference. Otherwise, destructive, we'll see. Fine. So this is what 2n pi. This quantity, what do we call this quantity? What is this?
Phase difference.
Phase difference. Good fun. This is phase difference. So this is the value of phase difference. Now there was one equation that we did, an equation that connected phase difference with path difference. Remember that equation? One equation was there which connected phase difference with path difference. See, phase difference divided by 2 pi is equal to path difference by wavelength. Phase difference by 2 pi is equal to path difference by wavelength. So let's find out what is path difference. Phase difference, we know it's 2n pi. Put it 2n pi divided by pi. 2n pi divided by pi is equal to x by lambda. So 2 pi gets cancelled. X is equal to n lambda. And n is what? N is still, this n is 0, 1, 2, 3, any number that you take. So it means if I say n, any number that I have taken, this is, let's say, 4. So what is the path difference? That will become 4 times the wavelength. It means 4 complete wavelengths. So this is what this is, path difference. So phase difference was 2n pi, path difference is n lambda. These things you have to remember. You will be having questions on condition of bright fringes, condition of dark fringes. So you have to remember these formula as well, right? And one more thing. What about the resultant amplitude then? We didn't substitute it, no? See, resultant amplitude will be what? R is equal to a square plus b square plus 2ab cos phi is what? Cos phi is 0, 1, 2, any number. It means cos theta is 1 only. So since we know cos phi is 1, so this 2ab into 1 under root. So this becomes what? A plus b whole square identity. Right? A square plus b square plus 2ab is the identity a plus b whole square only. So your square will get cancelled. R max becomes a plus b. So in your exam, if you are asked to calculate resultant amplitude for bright fringe, do not use the complete equation. Directly add the amplitudes. 3, 4, directly write it as 7. Fine. 3, 4 is it, directly write it as 7. Any 5, 5, 10. Any, just add it. Fine. Do not write all this of it. If you want, you can show the steps as well, but do not waste your time in writing cos theta, then figuring out what is cos theta. Theta is not given. No, it will be a plus b. One more thing. If this is a plus b, intensity maximum will be what? This will be k into R max whole square. Maximum intensity will be this only, no? So I max, intensity maximum will be k, R max square will be a plus b whole square. So these are the final conclusions for bright fringe. I am repeating: condition for maxima, bright fringe, constructive interference, any of the terms is asked. Phase difference will be 2n pi. Fine, n is any number starting from 0, any whole number. Then you have path difference as x is equal to n lambda. Fine, from 0, 1, 2, 3, any number. Resultant amplitude of the two waves will be a plus b, means directly algebraic addition of both the amplitudes. And finally, intensity will be what? Intensity will be the constant multiplied by a plus b whole square. So note it down. Any queries you have, let me know. Is it clear till here or not? Yes, class, clear or not?
Yes, sir.
Now see same things for dark fringe. Destructive interference, it means when the alternative thing superimpose, like the plus point coincides with the negative, that is crest with trough of the wave and trough with crest of the wave. Simultaneously it goes on. So that results in decrease in the amplitude, and you will obtain dark fringes over there. So since you are getting a minimum value of amplitude, minimum value of intensities, so here you obtain minimum. So maxima was in case of bright fringe, you obtain here minima. So minima, dark fringe, destructive interference. Any of these terms is valid. So here our minimum will be used. Here you will be having our minimum. So for the minimum value of amplitude, you have what? For the minimum amplitude, you have -1, right? So -1 is obtained when you get odd numbers. It means 3, 5. So if from 2n, if you subtract 1, then you will get all the odd values. Like if you had 2n pi, that was, let's say, 2 pi, 4 pi, 6 pi. So if you subtract 1 from it, you will get the odd numbers back. So here, just subtract 2n minus 1 pi. So this becomes what? 2n minus 1 pi. And start from 1, 2, 3. Okay, do not include 0 over here. So this will give you what? This will give you the value of the phase difference. Same things now. See, now phase difference is not 2n pi. The phase difference is now 2n minus 1 into pi. So your 2 will not get cancelled. 2n minus 1 into pi is there, and this is 2 pi. So only pi will get cancelled. X will be equal to 2n minus 1. This will be lambda by 2. This is the value of the path difference. Again, starting from 1, 2, 3, like this. So 2n minus 1, lambda by 2. This is the path difference. Now, here also, this you will putting a negative sign over here because you are getting a minimum value. This is not +1, no? Here it is -1. So this also becomes negative, this becomes negative, this becomes negative. So see, this is what? A square plus B square plus 2AB. Cos 180 is what? -1. Here we know that your cos phi is -1. So this becomes A minus B whole square identity. So minimum value will be A minus B. So intensity minimum will also be square of minimum amplitude. So minimum intensity will be A minus B whole square, like this. All right, copy it down quickly, then we'll do numericals based on this. So this is exactly same derivation, just negative sign is coming and everything is decreasing over here. See, the question says two waves in YDAC. YDAC means Young's double slit experiment have intensities I and 4I. You have to find out ratio of the amplitudes of the waves. You have to find out amplitudes of the waves from the two slits. See, I1 is equal to KA square. I2 is equal to KB square. Now from here, KK will get cancelled. A square by B square. What is I1? I1 is given as I2 is given as 4I. I will get cancelled. You get this as 1 by 4. So A by B will become 1 by 2. Fine. First part is clear to all of you? Ratio of amplitude, simply I1, I2, we just put the value of I1, I2. I1 was I2 was 4I. You take the ratio, that becomes 1 by 4. Since you are having square of the amplitude, so you take under root 1 by 4, that makes it 1 by 2. Fine. Second part says you have to find out the intensity of resulting wave with phase differences pi by 2. You have I1's value is I2 value is 4I. In the resultant intensity equation, it means this. I resultant was what? I1 plus I2 plus 2 under root I1, I2 cos phi. I1, you know, it's I2, you know, it's 4I. I1 again, this is I2 is 4I. Phi is already given to you in the question as 90 degree. Fine. So see, resultant will be I plus 4I plus 2 into I into 4I into cos 90 degree. Directly this term will be 0. Resultant intensity will be 5. Now, last part says what? Intensity of resultant wave with path difference is lambda by 2. So same question, but here you do not have value of phase difference. In the third part, you have x as lambda by 2. But can anyone tell me how can we find out phase difference? X is given. X is lambda by 2. So what will be phase difference? How will we find out the answer? We just have the intensity is resultant equation I1 plus I2 plus 2 under root I1, I2. So only X is given to us. 2n plus pi. Okay, anyone else? Yes, class, relation between path difference and phase difference. Didn't we do it? Second to your notes, you must have written it. There was a relation between phase difference and path difference. Yes.
Pi by 2 pi is equal to x by lambda.
Pi by 2 pi is equal to x by lambda. Correct. Yes, Hamza, right answer. It will be pi here. Because see, as Krishna correctly said, it is pi by 2 pi is equal to x by lambda. Please remember this equation. This equation is not just for the derivation purpose. Questions will be there from this. And you'll have to convert phase difference into path difference, path into phase difference. So x is lambda by 2. And this lambda is here. So lambda gets cancelled, 2 gets cancelled. So Hamza correctly answered, phase difference will be pi. Now we can keep it in our equation. Final answer we can get. Now we have phase difference. The way this identity was used, similarly here for the resultant amplitude I1 plus I2 plus 2 under root I1, I2 cos phi we'll use. So resultant intensity, this will be I plus 4I plus 2 into 4I into I into cos pi, 180 degree. So this becomes 5I plus, see 4I into I, this becomes 4I square. That makes it 2I. So 2I into 2 into minus 1. So what do you obtain? It will be I only, no? This is 5I minus 4I. That makes it I. So resultant intensity is I of t. This is how you will solve it if intensities are provided and rest of the things are asked to calculate. We'll do one more question where just the opposite will occur. Amplitudes will be given and intensities will be asked. So that you will try on your own right now in front of you. Question you all have written, I hope. If anyone wants to write the question, just let me know. I'll scroll up. Others, if you all have written it, then write down the solution. So two waves in Young's double slit experiment have the amplitudes A and 2A. So this time amplitudes are given. Ratio of intensities. Quickly answer this in the chat column. What is the ratio of intensities? First part is very easy. See, only Krishna has answered. Yes, correct. See, A and B are now given. I1 and I2 is unknown. Fine. So I1 by I2 is equal to K. K will get cancelled. A is given as A square. B is given as 2A. So that will become 2A whole square. So this becomes A square by 4A square. 2 square will become 4. So your answer will be 1 by 4. This will become 4A square. A square will get cancelled. I1 by I2 is 1 by 4. Fine. Also try the second part now. Phase difference is pi by 2. Amplitudes you have resultant equation of amplitude we did. So use that equation. Do not use intensity. This is amplitude that has been asked for you. And not only Krishna, what about others? You also answer at least the second part right now. Akifa, Atif, Fatima, everyone. Josefa, Sarah, Zain. And try the second part. Use the equation of resultant amplitude. A root 5. Okay, so Sarah, Krishna have given the correct answers. Okay, but at least Fatima, Krishna, Sarah, Zen all have tried. Good. See, let's discuss it. Now, the equation that you will use, this won't be this equation. Equation that you will use, it will be the different equation. Slight error, Hamza, slight error in your answers. Now, see, resultant equation, amplitudes equation is what? Under root a square plus b square plus 2ab cos phi. Pi is given to you as 90 degree, pi by 2. So it means this term is now 90 degree. So what are you left with? This becomes a square, this is a square, b square means 4a square under root because this term is now 0. As you know, cos 90 degree is 0. So what is left? What is now left? Root 5a square. So this is a, then root 5. So all those, just check wherever mistakes have been committed. Okay, Sarah has answered the third part as well. Good. So note down the solution and all of you try the third part. Third part is path differences lambda by 2, same thing. First note down the solution, then the third part. So only Krishna and Sarah have answered. I'll show you the question. Others, same thing. Path difference is given. Now tell what will be the amplitude of resultant wave. Your answers are correct, Krishna and Sarah. Others also try. What about you, Atif? No answers from you. Kulsum, Akifa, See, pi by 2 is not x, lambda by 2 is x. This is the difference. This is path difference. This is not phase difference that is given. Path difference, see, this part will be the same. X is given to you as lambda by 2. You will find out phi. Phi, that is phase difference, will come out pi using this. Now, once this comes out to be pi, so what will you do? You will substitute it in this equation. Resultant is a square plus b square plus 2ab cos phi. Phi is pi which you have calculated using x that was given as lambda by 2. Lambda by 2. This is not pi. Pi by 2 is 90 degree. That is different. Fine. Pi by 2, that was phase difference. This is path difference. Now see, resultant will be what? A square. B was what? B was 2a, no? Yes. So that will become 4a square. So plus 2a into 2a into minus 1 because this is cos 180 degree. Agreed. A square plus 2a whole square, that is 4a square. 2 into a into b into cos phi, that is cos 180 degrees minus 1. So this becomes 5a square minus 4a square. That gives under root a square. So r will be equal to, quickly note it down. Any doubts you have, let me know. These were very basic questions that are asked. We'll do some more questions also. Let us just at least have the concept and introduction of fringe width, distance from the centered bright fringe, all these things. Then we'll do some more numericals before we start with diffraction. Because numericals do come from this part, interference. Either theoretical questions or direct numericals come. Yes, all those who have to leave for Maghrib, you can leave. We'll just do a numerical so that you can, no need to join back. We'll do numerical. Next topic, we'll start from next class. So we have to practice one numericals that we'll do right now. See here, class. Same thing. Amplitudes are given two plane monochromatic waves propagating in the same direction with amplitudes A and 2A differ in phase difference by pi by 3. So pi by 3 is given to you. They superimpose with each other. So we have to find out the resultant intensity. So A1 is A, A2 is 2A over here, and phi is given as pi by 3. So again, amplitude's resultant equation we have. Amplitude's resultant is simply R. Let's write it as R. So R will be equal to A square plus B square plus 2AB cos phi. Now see, A square will be A square plus B square again, 4A square plus 2 into A into B, that is 2A into cos pi by 3. So cos pi by 3 will give you 1 by 2, half. So R becomes, this is 5A square, this 2 gets cancelled, that becomes 2A square. So that makes it under root 7A square. So resultant is A root 7. All right, note it down. Any doubts you have, let me know from the class. As you'll complete it, keep on texting me done, then I'll stop it. We'll continue with the next topic, that is fringe width and all. We'll start it in the next class. So 2 more classes are needed for wave optics, one for completion of interference and one complete class for diffraction. So after 2 classes, you will be having the test of complete wave optics. So start preparing all the topics that have been covered, Heinz principle at least. And do text me done in the chat column and any doubts if you have.